Let's continue with our example to predict the reaction time when is given the amount certain percent of the drug. Refer to the simple linear regression analysis of the drug reaction data performed in the previous example. Conduct a test at alpha 0.05%, 0.5, which is equivalent to 5%, to determine whether the reaction time Y is linearly related to the amount of drug X. We want to verify if actually a linear model can explain this relationship. If this linear model explains the relationship, then must have this formula. But if X doesn't explain the change in Y, like in this case, it's different to this other case. Actually, when X increases, Y also increases. And we can predict the value of Y, not exactly, but for this value, we can predict this value using the formula of this equation. Then the variation here must be due to other factors. But this factor, this variable, explain the change in Y. When we move X, Y also change. We can explain it. But in those cases, in this case, when we move X, Y is not affected. It's not affected. Then in this case, this factor, because Y really doesn't give me information about Y, X doesn't give me information about Y, this factor should be 0. Then when we cannot use this linear model to explain this relationship, we can assure that this value is 0. The slope is 0. When we have this cloud of points, the minimum value is this, the maximum value could be this, then the best representative of all value, all Y value for all of these points should be Y bar, the mean of all of these, and this could be my best estimator for all Y. The equation will be horizontal, and the horizontal line is written Y is equal a constant Y bar. That is the idea. Then for that reason, our null hypothesis, we are going to assume that the slope of my regression model is 0, and the alternative will be the slope is different to 0. Okay, let's start. That is my null hypothesis. The slope is 0. The model, the linear regression, doesn't explain the relationship, and the only alternative to predict Y is use the mean of all Y. There is no other way. The mean of all Y. Then my claim is different, the contrary of the null hypothesis. If we assume that the slope is 0, because we have a situation like this, if we select from this cloud a sample and we compute this, and this, and we try to obtain from this sample the line that fit best will be horizontal, will be a line that is the slope is close to 0, and the distribution of all possible b sub 0 from this kind of scatter plot, the center of the distribution will be b sub 1 equals 0 and is normally distributed. The standard deviation will be given by the standard deviation of all b sub 1. This is the distribution of all b sub 1 hat is given by the standard deviation for the error. Remember, we obtained it in the previous exercises, divided by this number. Then the test statistic, if we got this in my sample, this value in my sample, the test statistic is given by b hat sub 1 minus 0, and we want to compute how far away is this value from the center. Because if the cloud is like this, we are expecting that b sub 1 is 0. Then let's compute my t statistic. Then my t statistic is given by this formula. That is my evidence minus my expectation, in this case that is 0, divided by the standard deviation of the distribution of all b sub 1 hat. When we substitute all of this value, because we already obtained this value in the previous exercises, we obtained b sub 1 hat, that was 0.7. We obtained the standard deviation of my model, which is 0.61. And also we obtained the sum of square of all x. When we substitute all of this value in this equation, we obtain that my test statistic is 3.7. We are expecting 0 because if we assume that all my clouds cannot be explained in relationship using a linear model. Let's verify how far away is my evidence from my assumption. How far away is B sub 1 hat obtained from my sample from my assumption that B sub 1 is equal 0. This is a t-distribution. The degree of freedom of this distribution is n minus 2. In this case, we use 5 ordered pair. Minus 2 is equal 3. The degree of freedom is 3. Then, in that distribution, we expect 0, but my evidence fall in this point, 3.7. But how can we compare this value with my expectation? The reference value, in this case, is a total test. We need two critical value, and alpha 0.05 must be split. Then this area should be 0.025. Then we need to find which is my reference value in the table. The table for T student, in this case, the degree of freedom like 5 minus 2 is always n minus 2. Then the degree of freedom is 3. And because it's a total test, alpha must be split. The area in total is 0.05. And this area should be split in total, each one 2.5%. Then in the middle, we have 95%. Then this value in this intersection will be my reference point, 3.82. Then 3.7 fall far away from my expectation. That is my reference point. I am going to compare my evidence with this reference point given alpha, and we reject the null hypothesis because my evidence falls far away from my expectation. My expectation is this assumption. The mean is the slope is 0. Then in this case, we need to conclude that the slope is different to 0. Then if the slope is different to 0, my mathematical model look like this. This value is different to 0, then X will explain the variation in Y. My evidence falls here, and this is my reference point. It's a total test. I need 2 reference points. Then my evidence falls into the rejection region. And we can find this result in the printout. In the next slide, we have the printout of StatCrunch and SAS. It's given the mathematical model B sub 1 hat, B sub 0 hat. We can obtain this constant from any statistical software. The standard error, this quantity, the standard deviation of my model divided by a square root of this quantity is equal to this value. That is the standard error of the distribution of all B sub 1 hat and B sub 0 hat. This is my test statistic. Remember, we got 3.7, we rounded. And that is the p-value. That is the p-value because this p-value is smaller than alpha, is smaller than 0.05, that is alpha. Then we reject the null. Because p-value is smaller than alpha, my evidence falls far away from the center. We can obtain the same conclusion from the printout. We can obtain this p-value using StatCrunch. You have to go to StatCrunch, then in StatCrunch, go to Stat, go to Calculator. Stat, go to Calculator, t-distribution. You enter here the degree of freedom, in this case was 3, and your evidence was 3.6 something, 6533. Let's round it to 3.7, and let's compute what is the area, the extreme area, because that is the p-value. Probability to get this evidence or one evidence more extreme, because it's a total test, we need to multiply this area by 2. That's the value. If we multiply this value times 2, we will obtain 0.34. It's close to 0.35. I did it before, and that is the value that we have here, 0.035. That is one way to verify or to obtain those numbers using formulas and table.